Sis, do you see my handphone? Hey, you can see it. Oh, that's your handphone, right? Yes, that's right. Thank you, sis. Okay, so.
Hello friends! It's too long that I can see you, right? I'm so sorry because I have some text. By the way, did you know what's going on? That's right. Based on the title, I want to practice to be a teacher. That's for my homework. So let me show you and I hope you enjoy it. So let's go! Assalamualaikum warahmatullahi wabarakatuh. Hello everyone! How are you today? Are you fine? It's a really good day, right? If that right, you have more excited to have study today. So before we study, we have to pray together. So let's pray together. Pray start. Finish. I will check your attendance. Say present when I call your name. Okay, so I'm so excited to have you all here. Thank you, my student. By the way, my student, I have motivation for you. Did you want to know? If you want to know, I need to tell you something. It's your capable that you can realize. It's your time to make it rise and make it happen. So go ahead, make it happen because you have everything that you can need to change your life. That's my motivation for you, and I hope you can make wise decision. Because why you have uh, everything that you can need to change your life. So
Teacher,
how?
usage is so hard.
Okay, so maybe sometimes can be really cooked and tired, but you can pass it right. You can through it, and maybe pieces can be really difficult, but I believe you can master it by studying and practicing. So, so today we're going to study work. What we call work in Indonesia, that's it, gelombang. Well, can collaborate with the culture and smart. Is the kendang, which is Japanese musical instrument in Semarang. So today, I start with a present, a content, wave from the sound of kendang. Okay, first we will study definition, 2 type of wave, and 3 wave a quantity, and the last one is example with Semarang collaboration culture. That's it, kendang. So, for definition, wave describes the transfer of energy through a medium without the permanent displacement of the medium itself. That means when a wave travels through something like water or air, it carries energy from one place to another, but the actual substance is not moved. It's a traveling through a doesn't move permanently from the original position. For example, a stone dropped into a pond creates circular wave. The leaves move even though they are not touching because the energy of the stone vibration is transferred through the water. Okay, next for type of wave. First, types of wave based on the direction of vibration. We have number 1, transverse wave. Direction of vibration perpendicular to direction of propagation. That means the direction of particle vibration is perpendicular to the direction of a wave propagation. Example for the transfer wave is a wave on a string or a leg wave, where the particle of the medium move up and down or ascendwise, while the wave propagate is forward. Number 2 is longitudinal wave. Vibration direction parallel to propagation direction. That means the direction of particle vibration is parallel or coincident with the direction of the wave propagation. An example of the longitudinal wave is sound wave, like a sound wave of the kendang, where the particle medium is oscillate back and forth in the direction of the wave propagation. Example of the transfer wave is ocean wave, roof wave, and lake wave. An example of a longitudinal wave is sound wave and wave on spring or slinkies. The last one, type of wave based on the propagation medium. Number one, mechanical wave require a medium to propagate such as a water wave, roof wave, and a sound wave. Number two, electromagnetic wave do not require medium, can propagate in a vacuum, such as light, radio wave, and X-rays. Next, for wave quantities. The first one, we have amplitude, with the symbol is a capital A. Define amplitude as a maximum deviation, or we can call it with the maximum displacement of a particle from its equilibrium position. Second, for a wave quantity is wavelength, with the symbol is lambda. Define wavelength is a distance between two peaks or two values. Mention that wavelength is a typically measured in meters. Next for wave quantity is period, with the symbol is a capital T. Define period as a one full wave a period with the unit in a second. The last one of the wave quantity is a frequency, with the symbol is F. Define frequency as a number of waves per second, with the unit is hertz. But actually guys, in example with Semarang collaboration culture, in this video, we will looking for wave propagation speed from subwave of the condom. So let's solve this problem.
So the problem is a condom is hit to produce sound wave as in the picture below. Based on the picture, we know the type of wave is longitudinal wave. A longitudinal wave propagates from a point A to point D, taking 180 seconds with a total distance is 90 centimeters. So we have determined 1. Number of wave, 2. Wave a period, 3. Frequency, D. Wavelength, E. Wave propagation speed. Number 1, we have to determine the number of wave. The number of wave is represented by n. To determine the number of wave, it is necessary to know that one wave is one compression and one rarefaction. Based on the picture, the number of wave is 1.5 wave. Number 2, we have to determine the period. Period represented by capital T. The formula is a time divided by number of wave. We have a time is 180 divided by the number of wave is 1.5. We have in the result is 120 seconds for the period. Number 3, we have to determine the frequency of wave. We know the formula of frequency is 1 divided by period. So we have for frequency is 1 per 120 Hertz for frequency. Number 4, we have to determine wavelength or lambda, with the formula is distance from point A to point D divided by number of waves. We have for the distance from point A to point D is 90 centimeters divided by 1.5. So we have 60 centimeters for a lambda. Last one, we have to determine wave propagation speed. Wave propagation speed is represented by V. The formula is lambda divided by period, where we get lambda is 60 centimeters divided by period is 120 seconds, and we get a half centimeter per second or 0.5 centimeter per second for wave propagation speed.
Okay, that's all from me. I have a few questions for you. You can scan the QR code to test whether you understand the content I have presented or not. Thank you for watching. I hope this content is useful for you. And see you next my video. And bye guys.